In this video, I'm going to show you how you can place timers in your code to find where your code is running the slowest. This is the most basic function of a profiler. Profilers run along with your code to track the performance. Some advanced profilers will give you method level resolution and provide timings, CPU load, and various memory statistics like total allocations and garbage collection. Unity Pro has such a profiler built in, which is far more robust than the simple one I'm going to show you here. However, this simple version should get you started using the Unity free version. I'll also cover how you can use the information you find and when and where to start looking. Let's take a look at some code. The profile class is going to take care of most of the work for us. It's going to keep a list of time entries, where time entries have a name and a time, as well as a reference to when they were started and some indent information for displaying them. When we start a new timer, we're going to add an entry to our time entries and push the index of the timer onto a stack. When ending a timer, we're going to pop the last timer started off the stack and then add a new time entry referencing the last timer we started so that we can calculate the time it ran later. Peeking at the last time will give us the time run for the last time entry without removing it from the list. Next, we have a clear method that'll clean up our results. And finally, we have our write results method, which is going to go through all of our time entries, pair the start with the end, and calculate the total time for each timer. Let's take a look at an interface that implements this. This profile test interface is going to start a timer in its start method, run a method, and then end the timer and write the results. The outer process method is going to have some of its own timers, each wrapped around this process method, where process is just going to do some busy work and give us some timings. Let's take a look at this in Unity. Make sure you check uncollapse so that we can see how things actually happen in the correct order. First, we started our all of start timer. Then we started the process timer and ended a process timer. Took 0.24 seconds. We did that 2 more times here and finally stopped our all of start timer. It took 0.73 seconds in total. This information shows us that essentially the all of start method is simply a sum of each of the process methods. That means there's nothing else we need to look into here, and we want to focus our efforts on this process method. The process method is something we want to improve. How to improve code is something that's going to be very specific to the code we're improving, so I won't go into too much detail here. So how do we know when we need profiling? Typically, when a game is running slow, it has a low frame rate. This is because the time per frame is very high. In our example here, we're not doing much of anything, so we have a very high frame rate and a very low time per frame. Using the statistics information here, by clicking the stats button, we can gain valuable information about what our game is doing and why it might be running slow. For example, we can see that 0 time is being spent rendering because we have nothing rendered to the scene. And our main thread is taking 3 to 5 milliseconds per frame. This information, for example, could be used to determine if it's a code issue, drawing issue, or something else that's causing our game to run slow. If we see a low main thread time but a high render time, we might want to look at optimizing our meshes or reducing draw calls in some way. However, a high main thread time and a low render time would point to a scripting issue. We can narrow down the culprit script by enabling it or disabling it here in the inspector. We can go a step further and enable or disable an entire object by clicking up here. Once we've identified a script as running slow, inside the code of the script, we can essentially run a binary search using our profiling. For example, let's take a look at this large method here. We're just going to call that one method and see what comes out. We see here that that large method is taking 2.7 seconds to run. It's quite a long time. Let's see if we can narrow down the culprit. We might do this by a binary search method, which would simply be splitting our timers in 2. We can now see which half of the method is taking longer. We see here that the first half only takes 0.1 seconds. The second half is taking 2.6 seconds. Let's continue our binary split into the second method. Now we see that the slowest method is somewhere in the 2a section. So it's one of these guys. So finally, we can say process D and process E. And we can get rid of these other timers just to make things cleaner. Now let's take a look at that. Now we see that process E is the culprit here. This kind of binary search can help you quickly narrow down where your slow code is. The next step would be to go into process E and find out why it's running so much slower. We see here that it has significantly more iterations than any of the other methods. So the next question we ask is, how do we fix it? Here's a slow code checklist we can go over when trying to find out how to fix code. The first question we want to ask ourselves, is it required to run at all? For example, if there was another way to retrieve the data, could we do that? Or can we run the code once and then cache the results, not needing to run it anymore? The next question would be, is it required to run as often as it does? Could we use coroutines or triggers to activate this code instead of having it in the update loop? Next, is it required to run in as many places as it is? This example would be if we have multiple instances of a script, we could try and find some way to share the data or share the processing load. For example, pathfinding in a large scene, we could just pathfind once and use that pathfinding information for multiple characters. Finally, can we make it run more efficiently? The answer to this is almost always yes, but the next question to ask, is it worth it? This will depend entirely on the code we're running, but we might want to look into caching results or changing an algorithm. In this video, I've shown you how you can implement some basic timing to help track down code that's causing your game to run slowly. We wrap the method calls of interest with profiler calls to get the results about the time it takes for each of those method calls to run. Finding the code that's running slow comes with some knowledge of the codebase and experience with coding. Timings will help you narrow things down and confirm fixes to the code.